Hey guys, welcome back to Better C Sharp. Today we're going to be talking about a very important topic. I think this is probably one of the most polarizing topics in our industry, and I'm not exactly sure why. But you get like very different ends of the spectrum. You have like people that don't want to write tests, and you have people that are like super like test-driven development zealots, right? And honestly, it's kind of unhealthy for our industry to be like that, but tests, I think, are a good thing. I'm not like a super zealot or anything like that. I'm kind of in the middle where, like, I think that tests are very helpful. They have like a lot of benefits, and I think a lot of like the dogma around them kind of detracts from people wanting to use them, and I think that's unfortunate. So I do want to talk a little bit about tests, and I've got my notes up on the screen. I usually keep these off to the side, but I figured I'd put them on here this time. So why are tests important? They let you change code quickly and see if anything breaks. If you have, some class and you're like, this basically enables refactoring. You have some class and you're like, I figured out a better way to do this way faster, but I'm not sure if it works the exact same way. You've got tests, right? And you can make that change and just see if it works. And if it works, then hey, that's great. You can be reasonably sure that things are going to be okay. Uh, they can ensure that your bug fixes remain fixed. I think this is an important one. Whenever I'm fixing a bug, I try and write a test for it, and when that happens, you can be reasonably sure that that bug's not ever going to pop up again, because if it does, like, there's going to be a failing test. So that is also a good thing. Um, they ease debugging, and this one might be one that you might not immediately think of, but if you have something that you're trying to test, like without unit tests, and you have to do all this setup to get the program in a specific state, like that's annoying. And like you never just do that once. Like you have to do this like tens, maybe even hundreds of times to get something like just perfectly right, right? Uh, I mean, you guys have all know, like you've stepped through your same code like, 20, 30 times. It's super annoying to get to that specific spot in the program. But if you have unit tests, you can have a test that just gets you immediately to that state in the program, and you're good. Like you're there. Everything's great. So it really, I mean, it makes it easier, yes, but honestly, it just makes it faster. Um, it moves finding of bugs to development time. This is a pretty obvious one, I feel like, but this is a good thing. I mean, any bugs you can find yourself, that's amazing. And then any bugs that QA finds, like that's still great, but you probably it'd be ideal if they didn't have to waste their time finding it. And then I like finding out how to reproduce it. And then any that make it to prod, like that's terrible, right? So I mean, like it's really a good thing to be able to find your own bugs. And I mean, it's just really good. I'll stop there. uh, they let you try out new code before putting it into the real code base. This is maybe like an example of this might be like you've got some provider of some widgets, right? And these widgets have to be sorted, and you found a new way to sort these widgets to get potentially the same output, but way faster, right? But without tests, you couldn't be 100% sure, right? But with tests, you can be reasonably sure, not 100%, because you're not going to cover like every single parameter that can go into every single function. But like you can try the ones that you think matter pretty easily with tests, and I think that's great. But there is kind of a thing, like you have to set up your code in certain ways to get these benefits. And so we're going to talk about that for a second. We've got this section down here. We've got the project and solution structure here. Oops. Um, so to get the most benefit out of tests, you really need to set your project up in such a way that most of your logic is in libraries, right? Because you don't want to have unit tests for executables. In my opinion, I think that executables should be thin wrappers around a set of logic. And that set of logic is what you generally want to test. And like the thin wrappers are going to be like code that's like, you know, ASP.NET specific, or like setting up things to use your code libraries. So things that are like configuration specific, or like, you know, this is all going to be code that's like stuff that you probably don't want to test, because it's going to be like, you're going to be testing like database code or like Microsoft's code, or, you know, like not your own code, because these are such thin wrappers. So if you've tested the code in the libraries and you just have these tiny thin wrappers using third-party code to call your code, then like you've got everything covered, in my opinion. And this is really just a good practice in general, because if you keep your code separated and in the library, you can start calling it from wherever, you know, like, you know, you've got this pretty sweet website and it does all this stuff, and your boss is like, hey, can we automate doing this? Like, we have a new customer and they want to do this for a bunch of these things, and they don't want to have to do it through the website, but we have a list of all the things they want to do. And it's like, well, okay, well, if your logic is in controllers, like, that's not going to be easy to automate, right? But if your logic is in a library, you can just wrap that with a console app and call it a bunch of times. So that's kind of my spiel on how you should set up projects. And on that note, we have here this project setup right here. We're going to ignore these three for now. Those are going to be in a future video. But for now, we're going to talk about Net Worth Calculator console app, the tests, and the library called vehicles. So we have a library called vehicles. We have tests for those classes in that library, and then we have a console app that's going to call them. All right, so we have a program here, and we have some vehicles. We have a vehicle provider that uses those vehicles to give them off to the vehicle seller, I guess. Or no, we're using them right here. We have the vehicle, the offer provider, which gives back random offers. We have the vehicle cost calculator, which we talked about in a previous video. Is just, it has this calculate cost method. This is what the interface looks like. And then it just sets the base cost. We have this margin vehicle seller, right? Which just gives back, should we sell the vehicle based on the vehicle and what we're getting offered for it. So let's go look at the interface for that. So iVehicle seller should sell, takes in a vehicle and an offer, and gives back a bool, like should we sell it or not. And then we're just saying for each vehicle in vehicle provider.get vehicles, which just gives back an enumerable. And then we're getting a random offer from the offer provider. And then we're seeing if we should sell it or not, and then writing whether we should sell it or not. So to go back to our first point, well, first let's look at our tests. We have some tests for this. If you've never set up tests before, it's pretty easy to set up tests. So if you had, for instance, let's say we had a project called some project that had our logic in it, we would make some project.tests directory. And then we would .NET new, and there's 3 different kinds of test frameworks that are installed by default. There's XUnit, InUnit, and MS Test. I like XUnit the best because it's very easy to use XUnit to parameterize tests. So then once you've got your new project, you'll end up with something like this. And so XUnit has facts, which represent a single test saying like this test should pass. And then there's theories, which is like the parameterized tests. So anyway, that's how you set up one. Right here, we've got some tests here. I'm going to show you guys a couple of classes here. So the first instance that we have is a simple instance where like we've got our private party vehicle cost calculator that we looked at, right? And this is an easy thing to test because it has no dependencies, right? You just pass something in and get something back. It's like, it's the object version of like a function, right? So it's very easy to test. You've got predefined input, gives you a predefined output. So when you're testing, you have arrange, act, and assert. I don't normally put the comments, but for the video, we have the comments. So like our arranging is like we have a tank, and then our expected output value. If you go look at tank, it's 5,000 right there. And then our private party is 8,000 base cost. So those multiplied together gives 40 million. And then an assert that just says, hey, did these equal each other? This depends on what you write here, depends on your test framework as well. XUnit has assert equal. Different frameworks have different things. And there's also like extensions that kind of give you like a different way of writing it. But we're going to stick with the easy assert. And so now we have another one with cars. So we got a car, and we expect 8,000 because 8,000 times 1 is 8,000. And we get our expected result back. And then this is what I was talking about with the theory, with the parameterized tests. One way of doing it is with member data. So this is like, hey, look for a static method on this class that is called get cars and costs, and use that, and we're gonna pass that in each of these objects down here. So SUV gets passed in as the vehicle, and then 14,000 gets passed in as the expected. So that's our arrange kind of down here. So we don't need the arrange up here, and then we just act and assert. So the way these are structured, if you haven't noticed, is there's the name of the test, which is calculate cost, or the name of the method under test. So we've got our calculator that we set up, and we're testing the calculate cost method. And then there's like the options, like the conditions under which you're testing. So we're testing with a tank, and then there's the expected outcome. So this gives back correct cost. So that's kind of how these method names are set up. That's how I like to do it. But this is a super easy thing to test. Let's look at a more complicated one. Let's go look at the margin vehicle seller. So this one's a little more complicated because margin vehicle seller, if you look at it, requires a dependency, right? We got this I vehicle calculator. And what we're doing here is we're mocking that out. And what that basically means is we're giving an instance of a I vehicle cost calculator that we have control over, like what it returns from different methods and what the different properties are. So like if we weren't going to do this, what we would have is something like new private party vehicle cost calculator. But there's an issue here because if we were to do this, then we would be testing more than one thing at a time, right? We'd be testing the private party vehicle cost calculator indirectly, and any changes we made to private party vehicle cost calculator could make these tests fail. And that's kind of like not what you want, because you want your tests to only fail for things that you're actually changing. So like these tests should never change whether they pass or fail unless we're messing with margin vehicle seller, right? So that's why we mock things out. And mock MOQ is a great framework for this. So we're using mock MOQ. What that allows you to do is it gives you a very simple interface for creating this stuff. So we just make a new mock. You'll notice I always keep this stuff like as read-only member variables, so we can like use them in each of our tests. So we're saying, hey, we want to set up the calculate cost function. No matter what kind of vehicle gets passed, we want it to return 600 is what this is saying. So we're saying any kind of vehicle returns 600. And then our act here is like, let's see if we should sell, right? Our method name is should sell with too low of an offer returns false. So our calculated cost for the vehicle is 600. The offer is 500. This should be false, right? So that's kind of where we're going with this. Okay. So I'm just running the test. There's lots of different ways to run tests. Let's run all the tests in this file. Different editors have different ways of running tests, and you can even run the tests from the command line. So if we went to better C# here, test, we could do .NET test, and it knows like, hey, you're using XUnit, here's the adapter and everything, and it'll just run your test for you, and it'll give you output. A failed test here would look something like, let's say 800 here. And we'll rerun these out here as well. So a failed test out here is going to give you basically the same output as what we get inside Vim or inside Visual Studio or whatever you're using. So this is like, hey, we expected false, but we got true. So, and it gives you like a stack trace. So vehicle seller test line 28. So that's where we're at right here. Line 28 right here. So you get that same output down here. Like if we go to the end, we got false, but we expected true. So that's kind of how you can set up tests with dependencies. I want to illustrate this a little bit more though. Let's say that from now on, we've decided we want to start logging whether or not these things return true or not. So I'm just going to make public interface iLogger, right? And it's going to have a void log that takes in a string message. And we're going to say we want to take in one of these. So private read-only iLogger. Logger. We'll add a parameter there. And now if we go back to our program, we need an implementation of this, right? So let's say we just, for ease of use here, we'll just say public class console logger implements iLogger, and we will have to reload OmniSharp. I don't know why it does this sometimes, but we'll just go ahead and say public void log string message. We'll say console system.console.writeLine, and we'll just say datetime.now.to short time string, and then message. I think we have to bring in system for that. Yep. Okay. So now we can go over here and new console logger. All right. So now this should work, but also now in our tests, like we don't have all the things we need, but like you'll notice something, and we're going to talk about this more in a future video, but we have a dependency inversion thing going on here, right? So we have defined the console logger in the actual console app, right? This is in the console app. Let me see if I can get this a little bit over. Yeah, so console app is right there. We have our console logger in the console app, but we're using an interface that is defined in vehicles tests. No, in vehicles, sorry. So what that means is if we were going to try and implement, if we were going to try and run a test here, we would need to have an implementation of this, but our vehicles library doesn't necessarily need an implementation of logger. Like it probably doesn't, like from a library standpoint, you don't care how somebody else logs using your code. You just want to give them the ability, right? So we're saying, hey, we have this logger interface, we'll use it. You just have to supply an implementation, right? So that's dependency inversion. We'll have another video on that pretty soon. But we don't want to make one of these here is what I'm getting at. And we don't want to implement one just for the test. So what we actually want to do is create a mock for it, right? So private read-only mock of iLogger, logger mock. And that's not what we want. I think we just have to restart our server again. That's super annoying. Gonna have to fix that. But then we'll use logger mock.object. And now we should be good. Yeah. And so now we don't care, like, we don't care what logger does. In fact, if we call any of these, like, logger.log, testing from here, and we run these tests, like, logger mock doesn't actually do anything. So those calls to log aren't going to do anything, but we've supplied a logger. So now, oh, we actually have to instantiate it though. But we've supplied a logger to there. So, and you'll notice that we're using, whatever mock.object. The mock itself is actually the mock. So you can be like, hey, set up things or expect things or do whatever. The object is like the implementation that you get out of the mock. And what it's doing is, like, I don't know all the internals, but I think what it's doing is, like, at runtime, it's generating an actual implementation of these interfaces and then passing them in. So very cool stuff. And there's other things you can do with mocks as well. Like if we wanted to make sure, like, if we wanted to have a test that made sure that we're logging, for instance, we could do something like, logger mock.verify, right? And then m.log, and it is any string. So we're just, like, verifying that, and we'll say something like, what is it? It's times.once. Oops. So we're saying, hey, we want to verify that log was called one time exactly, right? And there's also, like, at least once. And then there's also, like, at least. So, like, 2 times maybe or something like that. I don't use these that often. Yeah, so we could do something like that. And then this test would be something like, there's not really any conditions here. We'll just say calls log, right? So if we ran this, hopefully it works. All right, the video is starting to get kind of long, so I'm going to go ahead and get to one more thing I wanted to talk about. So we talked about, trying out new code before putting it into the real code base. Like, if we now wanted to use a different type of, seller, right? Let's say we wanted to use one that's only an exact seller, like public class exact seller, which is I_vehicle seller. And we want to only return it if we get the exact cost, right? So we can say private read-only I_vehicle cost calculator, and we want I guess that's it. That's all we need. So oops. We'll create a constructor with this, and we'll just say return offer equals calculator dot get, or calculate cost of the vehicle, right? So this one only gives back true. We should sell if they give us the exact offer. I don't know why you would ever want to do that, but now we can have tests that are for this class before we've ever even used it in the actual program, right? So we can do public class, and if you haven't noticed, the naming convention here is like, exact vehicle seller, and then test. And so we'd be doing the exact same thing here, right? Like, we just want to get a calculator and a seller, and we want exact vehicle seller, and then we'll make a constructor. It has to be public for the test framework. And then we'll say calculator mock. Come on. Something. I guess a caps lock got turned on somehow. Crazy. Okay. Equals new mock of vehicle cost calculator. And then we need to new up our seller. So seller equals new seller, or new exact seller. And this needs a calculator. So calculator mock.object. I don't know why that keeps happening. So now that we have that, we can start writing some tests. So fact public void, and we'll say should sell with exact cost, exact offer, returns true, right? That's our test. We want to try and call should sell. So we want to range act insert. Our range should be, our calculator mock is going to return exactly 500, we'll say. We'll say setup, and we're saying our C dot calculate cost of any vehicle. Let's go ahead and close this so you guys can see. Any vehicle will give back 500 exactly. And then we're also going to say our offer, or our should sell, is seller dot should sell, and we're going to pass in a vehicle, so a new car or whatever, and then exactly 500. And then we're going to assert that should sell is true, right? And so I don't know if it likes to run multiple test classes in a single file. We'll see. Might not matter. Okay, cool. So that passes. Now we can go ahead and do the other side of this test, which is with a wrong offer returns false, right? And so we'll say if our offer is 200, then we want this to be false. And we'll run that test. Okay, so this is kind of what I mean when I say you can test new code. Like, we haven't used this before. We've never even instantiated it, and we have tests that say that it works, right? So that's super valuable, and I think like a great way to write code. I do want to say before we wrap up, and I'm gonna wrap up now because it's getting pretty long, but I see a lot of times where people will complain that they can't write tests for the type of code that they write, or that the tests that they write have to change all the time because they keep changing the code. And really, I feel like if you're writing the correct kind of code, this shouldn't be the case. So if you're writing code in such a way that you can pass in the dependencies, like in our class architecture video, you're following the solid principles. Like, if you're writing code that follows the solid principles, you can test it, period. Like, it's super easy to test. Like, this class follows the solid principles, right? And it's super easy to test. Like, even though it has a dependency on some outside thing, we can test it easy. And then the other thing was like the changing test code all the time. That shouldn't be the case either, because really, when you're changing old code, ideally you should be like fixing bugs or something like that, or adding very minute features. When you're adding like brand new like whole features, you should be making new classes that extend existing interfaces like we did here, right? And this warrants new test classes, new tests that don't even touch the old tests. Like, we added new features here and we didn't touch the old tests at all, right? So I don't feel like those are valid claims. So I think that if you're having trouble keeping your tests kind of static and keeping your code testable, like, I think you need to work on the code that you're writing outside of your tests. And I would highly encourage you to check out my other videos. Check out Robert Martin's book, Clean Code. I'm sure there's other good sources as well, but definitely look into it. But yeah, so I hope this has been useful for you guys. I hope it's been enlightening. If you like what I'm doing here, please subscribe, leave a comment. If there's things you don't like or would like to see change, leave a comment. I'm definitely open to all the feedback I get. I guess that's it. So thanks. See ya.